Have you ever thought of pouring liquid helium on mercury metal?
Well, that's what Heike Kamerlingh did in 1911, and what he created that day was a superconductor. A superconductor is a material which can go into a state where it has no resistance. But how?
Well, Onus's discovery had been a mystery to the world for a while until these three scientists, John Bardeen, Leon Cooper, and John Stryfer, who created the BCS theory.
Lattice ions in a metal would usually be vibrating due to the heat of the metal. So when electrons in a metal are moving around while a current is running through it, they bump into the ions that they're moving through. Imagine trying to walk through a crowd with lots of people and being slowed down from bumping shoulders with other people.
Similarly, electrons lose their energy when they bump into ions.
It's what's called resistance and why circuits can't run forever.
But slow those atoms down, and now they're a lot more chill, like a mini fridge made in the Arctic, and they don't move as much.
This means that the attraction between the cations of the metal lattice and the electrons is now noticeable enough for the lattice to pull towards the electrons. This movement in the crystal lattice is called a phonon,
Which attracts another electron to it due to the higher density of positive charge strong enough to overcome the repulsion of like charges. The second electron follows the other electron around as long as the distortion is present.
The two electrons are called a Cooper pair, which gain new properties involving quantum mechanics when paired up. There's a lot of mumbo-jumbo involved.
But it basically means that the Cooper pairs can clump together at the lowest energy level and synchronize. Furthermore, these pairs are attracted to each other over a long distance,
Relative to subatomic particles at least.
which means that their bonds overlap with each other and condense into an entity that acts with all its parts synchronized, as if the electrons linked hands and move together in a group now.
Moreover, these electrons are now entangled.
And the quantum level being entangled means that each of the particle's states depends on the other particle's state. Condensed electrons have greater resistance to bumping into ions, and the electrons that get knocked out of a pair can simply join another electron, meaning that while superconducting, a circuit would never run out of energy. Superconductors require extremely low temperatures to work, but there are better conductors that aren't explained by BCS theory, which will be far more practical. We'll have to wait, but soon we could have entire cities running on super.